Yeah. Really, when you're doing a limit, if you're doing direct sub on a limit, say like 5x, and you want to find the limit of that as x approaches 10 or something, you're plugging the 10 in for the variable, and then multiplying it by the constant out front. So you can take a constant and set it out front of the limit. So remember, we had the limit of x approaching whatever of 5x is the same as 5 times the limit as x approaches 10 of x. So you can take the 5 and set it out front as a constant. You can do the same thing with derivatives. It's something people kind of do automatically, but the official way of writing it is the constant multiple rule. Let's say if f is differentiable, at x equals c, or let's say f is differentiable. And c is a constant. Then we got the symbol d over dx. Remember what that means? We haven't used it much lately. Yeah, the derivative with respect to x. This is another way of saying if you got a function f, you can call it f prime, or you can say the derivative of f with respect to x. You'll see both of them written a lot this year. The derivative with respect to x of c times the function. Well, this is just like the function might be x and c might be 5, so altogether it would be 5x. That's all they're getting at. So the derivative of constant times function, if we pull that constant out front, how would that read? Constant times derivative with respect to x of f of x. Right, good. So basically you can reach in and yank out a constant, put it out front. For example, we actually already did that. We did that in this example, as a matter of fact. There was a 4 out front. And technically what we did was we pulled the 4 out, we differentiated x squared into 2x, and then said 4 times that, and we got our 8x. And you kind of do it automatically, but there could be times where you really need to sort of prove something step by step. If there's some technical little proof, it's good to know what's actually going on. So for example, if you have f of x equals 1/2, let's do x to the half power. Let's mess this up. F prime of x, really technically if you show all your work, would be the 1/2 constant out front would get pulled out. That's what this is saying. You can put the constant first and then differentiate the rest. Well, now you're just differentiating this. What happens there? You get a 1/2 out front again from the exponent coming down. And now you have x to the what power? Negative half, yeah. This has to drop by 1 full power. And if you kind of clean it up a little bit, 1/2 times 1/2 is 1/4. And then x to the negative 1/2. If you wanted to write that without a negative exponent, how could you get rid of that negative exponent? It is, okay, the 1/2 means it's a square root, and then the negative means it's in the denominator. Yeah, so the negative means it's now in the bottom, the 1/2 means it's a square root. So I guess that would be kind of the standard way of writing it, the simplified way.
square root of x.
The 1/2 power means a square root. That's where that came from. And then the negative exponent means it's in the denominator. Okay. Let's do a derivative of multiple terms. So if you got a polynomial, so far we've just been dealing with, oh, look at this cute little one-term function. Let's take its derivative. Oh, look at it, it's a one-term answer. Oh, same thing here, one term. Oh, it's one-term answer. If you've got a polynomial and you've got to differentiate it though, it's the Yoko Ono property again. Remember we had the Yoko Ono property with limits, where you could take the limit of each term individually, because you could rip them apart, like Yoko did to the Venus. All right. You can do the same thing with derivatives. What's that?
Someone ripped your heart out.
Oh, that was this one.
It's the, what's the name?
It doesn't matter. The derivative of multiple terms, you can, what this means is you can, in plain English, you can differentiate term by term. Take the derivative of each term in a polynomial, and you've successfully taken the derivative of that polynomial. For example, what do we got here? Yeah. Let's say y equals 6x cubed minus 2x. Don't make me edit this. Y prime then, we got two terms here. We're just going to differentiate the first term, get an answer for that. We're going to differentiate the second term, get an answer for that, put it all together, and that's our answer. That's our derivative. We're just differentiating term by term. So 6x cubed, the 3 is going to come down. What's our new coefficient then? Yeah, and let's just glue it all together. That's fine. 18, yeah, 6 times the 3 is 18. And then x to the what? X squared. Minus 2x is going to become 2, right? This is like x to the first if you want to think of it that way. The 1 comes down, 2 times 1 is still 2. And now you got x to the 0, which is just 1, because anything to the 0 power is 1, except 0. I just feel obligated to say 0 to the 0 power doesn't exist. Everything else is 1. Alright. Well, let's do a few more examples, kind of putting all these together. See, I figured we were good up to the purple line. That's why so I was just trying to go on one side or the other. We got g of x is negative 2x cubed over 3 plus, I think someone mentioned this before, 1 over x. We want to find g prime. Now, before you actually tear in and start differentiating this thing, it's probably going to be better to rewrite it so that your x, or your, so that your x's are all to a power. You might be saying, well, wait a minute, x, right now it's 1 over x to the first. What's the big deal? Here's what won't work. This worked with limits, but it won't work with derivatives. With limits, we could take the limit of the top of a fraction and the limit of the bottom of a fraction. That doesn't work with derivatives. You can't say, oh, derivative of the top over derivative of the bottom. Doesn't work. So what we want to do is we want to rewrite this first so that it's not a fraction. We'll talk about how to differentiate fractions later, but But this one you don't even really need to. You can just make it not a fraction. Let's say instead g of x equals, well, I'm at it. I think I might take that x cubed and put it out front and just make the negative 2/3 a coefficient. Is that all right with everyone?
Yeah. Let's do it.
And instead of calling this 1 over x, that's really just x to a power. Yeah, negative first power. Because technically right now, it's a positive one in the denominator. If you want to bring it up to the top, just switch the sign on the exponent. So it's really x to the negative first. Just like over here, we had a negative half power, so we wrote it in the denominator and made it a positive power. Well, it works the other way too. If it's positive in the denominator, write it in the numerator as a negative. And now it's just a g prime. You can just differentiate term by term. So the 3 is going to come down as a coefficient. Yeah, it's going to get multiplied by the negative 2/3. You're going to end up at negative 2, right? Just going to take Andrew's word for it. Oh, that's leadership. X cubed is going to become x squared. And then we just differentiate this term. What's going to be our coefficient? Negative 1 is coming down like a contestant on The Price is Right. Now we got x, yeah, this has got a drop of power, so negative 1 drops to negative 2. This is x to the negative second. That can be cleaned up a little bit.
Over x squared.
Yep. Negative 2x squared, I guess not so much. The plus and negative, let's just call that minus. And then the x to the negative second, let's drop that to the denominator so that we can call it x to the positive second. I got good closure. Look at that. I'm glad that's.
Can't remember that's
Yeah. I'm glad that's on. You can tell I'm old. I wanted to say tape. I'm like, well, that's not really the right word. So I'm like, it's film. No, that's even worse. I got it on file. On record. There you go. That's good. Oh, a couple more of these, and then I'll give you some to try on your own. Let's do the derivative with respect to x of. We got negative 4. That's a cube root of x squared. Negative 4 times the cube root of x squared plus 8x squared minus x plus 2. So negative 4 cube root of x